All right, let's see here. Looks like we're going to be doing Algebra 2 lecture for 10.5 and 10.6. That's OAS A2A14. Student will factor quadratic trinomials. First, factoring out the greatest common factor. Okay, and we're going to talk about what that looks like and how we do it. Quadratic trinomials are written in the general form ax squared plus bx plus c, where a, b, and c are going to be some constants, like some number, 2, 7, 14. These will be numbers, and these x's will just remain x's. So this might be 3x squared plus 6x plus 18, or something like that. That's the general form. What we've been doing so far in factoring quadratic trinomials, the coefficient of x squared, that's the number in front of x squared, a, has been a 1. It's been an implied 1. You can't see it, but it's there. 1 times x squared. What we're going to do today is, if a is not 1, check to see if each term has a as a factor, and if so, factor it out and then factor the remaining quadratic trinomial. So we're going to divide each one of these terms by whatever this is, if we can, factor it out, and then factor the resultant quadratic trinomial. That's the plan. Here's what it looks like, hopefully. Factor completely. I'm looking at this, I see that A is 3, B is 6, C is negative 144. So I'm going to see, first of all, I'm going to check to see if there's a greatest common factor. And I see that all three of these will divide by 3. Okay? 4 plus 4 is 8, plus 1 is 9. That's the test to see if the sum of these digits is divisible by 3, then this number itself is divisible by 3. So I'm going to divide all these by 3, factoring out the 3. The 3 isn't disappearing. I'm just going to say, okay, this is 3 times k squared plus 2k. I've pulled the 3 out of there. When you pull it out, you're dividing each term by 3. This is 1k squared. 3 divided by 3 is 1, invisible or implied. Minus 144 divided by 3. Well, 3 goes into 14 4 times, has a remainder of 2. 3 goes into 24, 8, is that right? Let me check that with my calculator. My brain is not working correctly this morning, as usual. 144 divided by 3. Yay, go me. So now I've got this, that's the greatest common factor that I've factored out, and I've got this remaining quadratic trinomial, and I'm going to try to factor that. This 3 isn't going to disappear. It has to stay right as one of the factors. Stay right there. I'm going to take the square root of this one now, pretend like this is gone, and we're just going to factor this. Take the square root of this one and put it here and here. Now I'm going to look for factors of 48 that have a sum or a difference of 2. They'll either, the factors, that's numbers that we can multiply together to give me 48, and those same numbers will add or subtract to give me a 2. So I could try 2 and 24, but those won't add or subtract to give me a 2. 3 and 16 won't add or subtract to give me a 2. But how about 6 and 8? 6 times 8 is 48, and 8 minus 6 is 2. So I'm going to try 8 and 6 and see how that works. Doesn't matter where I put the 8 and the 6. I could put the 6 here and the 8 here. That doesn't matter. What does matter is that these two numbers must add up to positive 2. And the only way that can happen is if the 8 is positive and the 6 is negative. And then here's my check to see if I factored this correctly. I make sure that these two numbers multiply together to give me negative 48, which they do. And then I make sure that they add together to give me positive 2, which they do. So providing that I factored this 3 out correctly, and I've already checked it, 3k squared plus 6k minus 144, this much is factored correctly. Then from here to here, I just did that check. These two multiply together to give me this one, and they add together to give me that one. This is factored correctly. And it's factored completely. The first thing I did was factor out the 3. but this could also be factored. So I went ahead and factored it. Okay, let's do another one. Look up here, I see that A is not a 1, so I'm going to check to see if all of these will divide by 6. Okay, so here we go. I'm going to try to pull out a 6. Try to factor out a 6. That leaves me with A squared minus 11A plus, let's see, 6 goes into 16 twice with a remainder of 4. 6 goes into 48 8 times, is that right? Again, let me check my arithmetic because I'm a brain damaged old man. 168 divided by 6 equals 28, yay. So now I'm going to try to see, I factored this out correctly. There's 6A squared minus 66A. 6 times 28 is 168. I just checked that with my calculator, so yay. Now I'm going to try to factor this remaining quadratic trinomial and see what we get. I'm going to try to break it into 2 quantities. I'm going to take the square root of this one, put it here and here. Then I'm going to look for factors of 28. Those are numbers that I can multiply together to give me 28. Numbers that will multiply together to give me 28, and the same numbers will add up to 11. Add or subtract and give me an 11. So here we go. 2 and 14 won't work. How about 7 and 4? 7 times 4 is 8. 7 plus 4 is 11. Let's try those and see if they work. Doesn't matter where I put the 7 and the 4. I could put the 4 here and the 7 here. Doesn't matter. What does matter is that these must add up to negative 11. And the only way that can happen is if they're both negative. Negative 7 plus negative 4 is negative 11. So I've gotten it factored. Now I'm going to check to see if I factored it correctly. These two numbers must multiply together to give me positive 28. Negative 7 times negative 4 is positive 28. And they must add together to give me negative 11. And they do. Negative 7 plus negative 4 is negative 11. So I checked to make sure that this was factored out correctly. And then the resultant, or the remaining quadratic trinomial, I factored it, and I just did the check on that. So we can say that we have factored it correctly and factored it completely. Okay. Hopefully this is making sense. We'll do a couple more. Oops. Okay. I see here that this number, we're going to call it A. The coefficient of the quadratic term. The coefficient of the quadratic term, that's the coefficient of the linear term, and that's the constant. These are all three going to be numbers. This coefficient of the quadratic term, A, is a 5. So I'm going to see if I can divide all of these by 5, and I can. So I'm going to factor that 5 out. That gives me 5 times the quantity m squared plus 4m plus 3. In factoring out this 5, I divided each of these terms by 5. And now I'm going to check to see if this remaining quadratic trinomial will also factor. If it will, I'll factor it. If it won't, then this will be my answer. Okay, sometimes they'll factor, sometimes they won't. In this case, I'm going to try, remember this 5 doesn't disappear. It's one of the factors of that trinomial. And we're going to see if we can find a couple more factors. I'm going to take the square root of this one, m. The square root of m squared is m. And I'm going to look for factors of 3. That's numbers that can multiply together to give me a 3. And the same numbers, the same two numbers, will add or subtract to give me a 4. Well, 3 is prime. It only has 2 factors, 3 and 1. So luckily, 3 and 1 add up to 4. So I'm going to try and see if I can factor that using 3 and 1. They have to be able to add together to give me, or multiply together to give me 3. And more importantly, they have to be able to add together to give me positive 4. It doesn't matter where I put the 3 and the 1. I could put the 3 here and the 1 here. That doesn't matter. What matters is these must add up to positive 4. And the only way that can happen is if they're both positive. Positive 3 plus 1 is positive 4. And then I do a check. Is positive 3 times positive 1 positive 3? Yes. And then 3 plus 1 is 4. Since it meets both of those criteria, and I've factored out the 5 correctly, I can check that and just by using the distributive property and making sure that I get what I started with. I've done a check on everything, so I can say that I have factored this quadratic trinomial completely. Okay? That looks kind of like it's going downhill. Okay, I'll move this over a little bit. All right, looking at the last example here, I see that A is a 2. And look at here, that is x cubed and x squared and x. This thing has a common factor of 2 in it, and every single term has an x in it. So I'm going to pull out a 2 and an x. Let's see how that works. I'm going to pull out a 2, and I notice that was x cubed. That's not quadratic. So in order to factor a quadratic, I've got to see if I can pull an x out of all of those, and I can. So I'm pulling out a 2 and an x. And I'm going to write what's left from each term if I pull a 2 and an x out. If I pull a 2 out of this, remember when you pull it out, you're dividing. If I pull a 2 out of this, I'm left with 1. If I pull one of the x's out here, I'm left with x squared. If I pull a 2 out of this, I'm left with -1. You can put a 1 there if you want, but it's implied. And if I pull one of the x's out of here, by dividing, I'm left with the other x. And you can put a 1 here if you want. You can think of it as -1x. It is -1x. We just usually don't write the 1. And I'm going to pull a 2 and an x out of this. Well, if I pull a 2 out of this, that leaves me with -72 if I do my arithmetic correctly. And if I pull an x out, remember you're dividing when you pull it out. X divided by x is 1. 1 times 72 is 72. So you can think of it as 72 times 1, but there's no need to write that because 72 times 1 is 72. Alrighty? So I factored out 2x out of every single one of these. And now I'm going to check to see if I can factor this remaining quadratic trinomial. So here we go. This won't disappear. This factor of 2x remains a factor. And I'm going to take the square root of this one, this quadratic term, and break it up into 2 factors. And now I'm going to look for factors of 72 that will add or subtract to give me a 1. Well, 2 and 36 won't work. We could mess around and see what we come up with, but I think, 9 times 8 is 72, isn't it? Check, my brain is damaged. 9 times 8 equals, yay, 72. So I'm going to go 9 and 8. They will multiply together to give me 72, and they'll add or subtract to give me a -1. And the important thing, again, we can put the 9 here and the 8 here. That doesn't matter at all. It doesn't matter where the factors go. What matters is they have to add together to give you a -1. That's the important thing here. And the only way that can happen if we add these two together and get -1 is if the 9 is negative and the 8 is positive. And then I do my quick check. I already checked this. This is 2x cubed minus 2x squared minus 144x, so I've got that. And now I'm checking this. These have got to multiply together to give me -72, and they do, 8 times -9. And they've got to add together to give me -x, -1x. And again, you don't have to put that 1 in there. Whoops. I'll go ahead and leave it. But if it just said minus x like this, minus x means it's the exact same thing as -1x. There's an implied 1 there. So you can write it like this and just remember that that's a 1. So I was checking. 8 times -9 is -72. 8 plus -9 is -1. So they multiply together to give me this one. They add or subtract to give me this one. And so I know I've got it factored correctly. And I have factored this quadratic trinomial. Well, that's not quadratic, but it would be, it is once I factor that out. I factored this trinomial completely. Okay? I hope that makes sense.